this is my linear side, and this is my angular terms. When a body is rotating and when the body is linearly moving. Okay. In linear terms, if we have mass, that is my m. In angular terms, I will have
Moment of inertia.
very good momentum of inertia. That is how we denote this. I. Okay. In linear terms, if I have this, what is this position vector or angular position? Sorry, linear position. Okay, linear position. In angular terms, I will have angular position. Okay, its unit is meters. Its unit is radians. Change in position is final position minus initial position. What is that? Linear displacement. Okay, in angular terms, we have angular displacement delta f, delta theta. Theta f minus theta I. Okay, so this is my angular. Or I can write what is the difference between this d theta and delta theta? Basically same. This is very small change. This is not very big, just finite change. This is very infinitely small change. Infinitely small change and finite change. Finite change is delta and very small change is differential. We call this as differential change also. Okay, here also we can write dr. What is this dr? Infinitely small change, infinitely small displacement basically. Okay. Now, can you tell me after this we have velocity, linear velocity. How do I write linear velocity? Displacement divided by time, dr by dt. Okay. In angular terms, this is linear velocity. This is called angular velocity. Okay. What is the unit of delta theta? Radians. This is radians. Angle minus angle is basically angle only. Okay. Now omega I will write as d theta by dt. What is its unit? Radians per second. What is the unit of this? Meters per second. Okay. After that, linear acceleration. Either I will write it as d square r by dt square, or I will write it as dv by dt. Correct? Now here, if this is dv by dt acceleration here, this is linear acceleration, angular acceleration. How do I show it? Alpha. This is my angular acceleration. Now angular acceleration will be my, tell me, d omega by dt. D omega by dt. So what will be its unit? Radian per second square. What will be its dimension? T minus 1. What will be dimension? T minus 1. Radius does not. Dimensionless, but not unitless. Okay. After this, acceleration. After this, a force. Okay, let's start with force. Or let's start with momentum first. Or let's start with force. Force. Here we have force. Here we have. This is linear force and this is angular force. This is angular force we call as torque. Okay. Force is equal to mass times acceleration. Torque is equal to either r cross f. For a rigid body, I will write it in terms of moment of inertia. What should I write in place of m? I should write it I. Okay. In terms of A, I should write alpha. So I into alpha is my torque. I into alpha is my torque. Understood?
Yes.
Is it clear? Now next, linear momentum. What is it equal to? Mass into velocity. Mass into linear velocity. Okay. Angular momentum. How do I show it? L. Either it's r cross p or m r cross p, or I can write it as I into omega. I into omega. Clear? Okay. Then next.
Yes, sir.
After this, what do you write?
Kinetic energy.
Kinetic energy. Okay, very good. Kinetic energy. How do I write kinetic energy? Half mv square. This is linear kinetic energy. If an object is traveling in a linear path, this is velocity, it's mass times velocity square divided by 2 will get kinetic energy. Okay? Kinetic energy. What is the unit? Joules. What is the unit here? kg meter per second. What is the unit of mass? Force Newton. What is the unit of torque? Newton meter. So how do you write r cross f? R f meter, Newton meter. Okay. Now here kg meter per second. Okay. So similarly we can write that mRV like that from there. Okay. Now can you tell me kinetic energy is joules? In rotational kinetic energy, how do I write that? R I omega square. This is rotational kinetic energy. After this, what do you write? Nothing. That's it?
Yes.
Can you tell me work power energy? What is work equal to? Into?
Force cross S. F cross S.
Force cross S?
Sir, F dot S.
Into. How many types of multiplication do you have in vectors? Two types, dot and cross. R cross F is also multiplication. Dot is also multiplication. Dot is called as scalar. Dot is called as scalar product. Cross is called as vector product. Why is dot called scalar product? Because answer is scalar. Why do you call cross product vector product? Answer is vector. For can you give example of one cross product? One product. Dot. Not force. Force is basically scalar multiplied by vector. Dot R cross F. Position vector times force vector. Okay. Answer we get as dot vector or scalar. Any other example of cross product? Angular momentum. R cross P. R cross F is dot. R cross B is angular momentum. Okay. Moment of linear momentum is angular momentum. Moment of linear force is angular force. Do you understand?
Yes.
Moment of force is torque. Moment of angular momentum is. Moment of linear momentum is angular momentum. Okay. Now dot product. The answer will be scalar. Is what scalar or vector? Scalar. So that's why we use dot. What is dot? F dot S. Dot product of F and S. Or I can write it as Fs cos theta also. Understood? Now, angular work. Angular work. Tell me. Torque dot theta. Torque dot theta. If they have same direction, they have. If torque is also clockwise, angle, the angular displacement is also clockwise. That means delta theta is also clockwise and torque is also clockwise. In that case, the angle between them will be zero. But sir, how are we saying clockwise as 0, 0? Because we take our hands and curl it in the direction of torque. The thumb we use as the direction k cap. Minus k cap or k cap. For example, an object is revolving in a clockwise direction. Like this, clockwise direction. Okay? Its angular displacement will be which direction? Will it be clockwise or anti-clockwise? Clockwise. But how will I write it? Will I write clockwise?
No.
I will write in terms of unit vectors. How should I write that? That's why we call these vectors as action vectors. We call these vectors as action vectors. Now, take your hand, right hand. This will give you a sense of rotation. Thumb will give you how to write it. How to write it. Tell me, what is the right? Minus k cap. Okay, it is anti-clockwise plus k cap. Now imagine it's angularly displacing clockwise. Let's say delta theta. How much? Delta theta. Okay. Delta theta. So torque is also, let's suppose, clockwise. Torque is also clockwise. So for delta theta also minus k cap. Do you understand? And torque also minus k cap. What is the angle between minus k cap and minus k cap? Zero. So usually, we take all 0 as 1. So simply we write as torque going down is equal to, in terms of force, what should I write? Torque. Okay. Multiplied by what is S? Theta, not theta. Delta angular displacement. Understood? Torque multiplied by angular displacement is my angular work done. Is my angular work done in terms of angular. Okay. Anything is revolving. Okay. थोड़ा आगे समझ में. We'll do questions on the basis of this also. Okay. Don't worry. Okay. In one power energy, those who have attended the class maybe or from the basics also, you can tell me what is power equal to?
Joules.
Power is equal to work by time. No problem. Work by time. What is work equal to? F dot S divided by time. F dot S divided by time. What is displacement by time? Velocity. Remember another definition. The power is basically F dot B. F dot B. The dot product of velocity and force. Dot product of velocity and force will give you power. Are you getting my point? Is it clear? Do you understand how I got to this? Yes. Work done divided by time. Work is F dot S. S divided by T is velocity F dot B.
Sir, you said angular work done will be equal to 0 when the direction of torque and angular momentum is same, right?
Not 0, because cos 0 is equal to 1 maximum, no?
Yeah.
That time maximum.
But in angular.
Angular also. See, clockwise, both k cap. Angle is 0. Both vectors are 0 angle. Or don't go k cap. See, one is clockwise, another is also clockwise. So angle must be 0. If one is clockwise, another is anti-clockwise, then it's cos 180. It could be. Okay, I will explain you how. For example, in linear terms, I will explain you. Imagine a car is moving with some velocity. An object is moving with some velocity. Understand this? This is very important. Huh? You know, this chapter will revise you the previous chapters because I told you this is whatever we have studied previously will be used here. Basically, Newton's law in terms of rotation. Do you understand? Okay. Now, for example, this is an object having mass m, M. Let's say it's moving with some velocity v. It's moving with some velocity v. If the net force is 0, imagine this is a very important concept. If the net force is 0, will the velocity change? No. Velocity will not change. It will stay in the state of uniform motion. Do you understand? For example, the net force is 0, so it will not change. But if net force has some value, For example, the net force is in the direction of velocity. Tell me, will the velocity increase or decrease? Definitely. If I push something, something is moving, pushing it, so its velocity will increase. If its velocity will increase, can you tell me, net force is equal to mass times acceleration? If net force is equal to mass times acceleration, can mass be negative? No. So whatever the direction of net force will be the direction of acceleration also. So in this case, acceleration will be also positive or negative? Positive. What is this case? Is it speeding up or speeding down? Speeding up. Is it a positive acceleration or a negative acceleration? This is a positive acceleration. This is the case of acceleration. This is the case of acceleration. Today's topic very important. I will explain to you why I am teaching you again. I will relate this to angular terms. Okay, clear? Now, any body M is moving with some velocity forwards. A car is moving with some. Okay, can you tell me in terms of car? Okay, this is a positive acceleration. This is a positive acceleration. That means the value of acceleration I will get as positive. Okay, this is positive. This is positive. This is also positive. Its velocity will increase. Velocity will increase. Understood? Clear? Now here I will tell you. This is basically when I apply brake. Sorry, when I apply accelerator. In that case, see if I keep my feet on the accelerator, the car is moving in a straight line. If I balance that, I am balancing basically the net force. Okay, the forward force and backward force. The net force will be equal to 0. That's how I maintain. By keeping my paddle on this, I just. Do you know how to try?
Yes, sir.
You know how you maintain this constant velocity? Do you press the accelerator?
Yes, sir.
Do you press the accelerator for maintaining
Yes.
the constant velocity?
No.
Do you release the accelerator?
No, sir.
What do you do?
Press it,
Just
hold
go.
Keep it at some point.
Yes, sir.
Okay.
This is not-
Maintain. What you are doing is maintaining the forward force and backward force. The force by the engine and the force by the friction. The force by your balancing. If forward is 500 Newton, backwards is 500. Now, in order to accelerate, you have to give net force in forward direction. In that case, you press the accelerator. You press the accelerator, and the velocity of that object will start increasing. It is accelerating. Understood? Now, can you tell me if now the net force is backward direction? Acceleration in which direction? Backward direction. If we take forward as positive, acceleration backward as negative. So acceleration will be positive or negative?
Negative.
Net force will be positive or negative?
Negative.
So is this a case of acceleration or deceleration or retardation? What is retardation basically? When acceleration is negative. Negative means when it's opposite to the direction of velocity. When it's opposite to the direction of velocity. Some of you got confused, sir. If I take this up to me, I'm giving some extra thing. Okay. If I put forward as negative, it's up to me. Okay. Forward as negative, backward as positive. In that case, this will be positive. I will call this as. So here it will be both will be negative. Acceleration will be also negative. Here the acceleration will be positive because I have use the convention forward as negative, backward as positive. It's up to me. But usually we do not do that. Okay. Forward as positive, backward as. That's why the negative acceleration comes here. But the proper definition would be if the net force is opposite to the direction of velocity. You understand? The acceleration will be negative. Acceleration will be negative. You can understand in free fall also. Okay. When I drop an object, the object is coming down. What is the velocity? Downwards. What is the acceleration also? Downwards. So it is acceleration or retardation? Acceleration. So the body accelerates. It's called free fall with the acceleration of constant acceleration of 9.81 meter per second square. Now if I throw a body upwards, velocity is upwards, acceleration is downwards, net force is downwards. It is the case of acceleration or retardation.
Retardation.
Do you understand? This is the basic. Now did you understand this also? Is it clear? Can you tell me if I apply? This is first case. This is second case. This is third case. Now look here. I have an object. It's moving with some velocity v. I apply a force not in direction, not in opposite direction. I apply the net force perpendicular. To the direction of velocity. Can anyone tell me, will the speed increase or decrease? Or remain same?
Remains same.
It remains same. What will change?
Direction.
Velocity will change. Speed will remain constant. And this force will provide you centripetal force. And this thing is going to move like this. In a circular and perform uniform circular.
Sir, can you explain again?
See, here velocity was in the direction, the velocity increased. Here the force was opposite to the direction of velocity decreased. If the force is perpendicular to the direction of velocity, in that case what will happen is speed will not change. Speed will remain same. But what will change is direction. Basically velocity will change. Every point of time I will see that it will move with the same speed. If here it's 10 meters per second, here also it will be same 10 meters per second. But I will make it tangential, okay? So 10 meters per second. But the thing is, the speed continuously remains the same, but the velocity at every point of time changes. So what is changing the velocity of this object is the force. Which force? Centripetal force. And this centripetal force is provided by some forces, I told you. Okay. In case of moon, when moon is revolving around the earth, the gravitational force between the moon and the earth is providing centripetal force. When the electron is revolving around the nucleus, the charge, positive charge and negative charge attract. The electric force is called electrostatic force. This electrostatic force provides the necessary centripetal force. Are you getting my point? If I tie a stone with a thread and move it, the tension in the rope will provide me centripetal force. Are you getting my point? Is it clear? Yes or no? Now I will relate this thing with rotation. Now understand. Now for example, this is an object and this object is revolving, performing rotational motion. Performing rotational motion. Okay. Now let's say why are we laughing? Let's say its displacement or its angular velocity. Now I will not say linear velocity, but let's say angular velocity. Let's say its angular velocity is omega. Angular velocity is omega. Okay. Is this omega clockwise or anti-clockwise? Clockwise. Minus k cap or plus k cap? Minus k cap. Very good. Now can you tell me if the torque, if there is no torque, for example, first thing, if there is no torque, it will maintain its angular velocity. Do you understand? First, like here, if there was no force, it will maintain its uniform motion. Here, it will maintain its linear velocity. Here, it will maintain its angular velocity. When there is no torque, here, when there is no force, it will maintain its linear. Are you getting the point? Are you trying to relate? Are you getting it? Now, what if I provide the net torque? What if I provide the net torque in the same direction as that of omega? Will there be acceleration? If there was no torque, net torque was 0. What was the acceleration? 0. Alpha was 0. When this object was, there was no force. What was the A? 0. A was 0. What is A? B minus 2 divided by T. Okay. Final velocity, initial velocity is same. So there will be no acceleration. Similarly here, there will be no acceleration if there is no torque. Which acceleration? Angular acceleration. But if there is torque in the same direction of omega, alpha will be there. Tell me, will the alpha be positive or negative? Positive. Alpha will be positive. That means this angular velocity continuously starts to increase. I am pressing accelerator. Do you understand? In terms of rotation. When you start a fan, from rest, there is a torque in clockwise direction. Angular velocity clockwise, torque also clockwise. If you accelerate in clockwise direction, then it will come to a constant speed. When it comes to a constant angular speed, alpha will become 0. When I stop the same fan, now the torque. Now this is another case. Look at this. Let's say now this fan was moving omega, okay, with some angular velocity omega. I apply net torque. Which torque? Net torque. Net torque is basically also the sum of all the torques. Today we will do question on the base of that. Force was sum of all the forces. Net force was sum of all the forces. Similarly, torque is also the sum of all the torques. We'll see which is clockwise torque, anti-clockwise torque. One will take as positive, one will take as negative. We will solve it. Are you getting this?
Yes.
Are you getting it also? Yes. Now in which direction will I apply torque?
Backwards.
Backwards. If I apply torque backwards, if I apply net torque backwards, look here, the acceleration was negative. Velocity was forwards. Net force was backwards. Acceleration was backwards. Similarly, torque is backwards. The acceleration also here. The acceleration will be in the same direction. Here, the acceleration will be in the backward direction. Okay, one thing. In terms of k, let's understand. This will be minus k cap. Okay. Torque will be plus k cap. Plus k cap. Plus k cap, right? Torque will be plus k cap. Omega will be minus k cap. Opposite to each other. Alpha will be also plus k cap. Omega will be minus k cap. Will this velocity, will this here increase or decrease? Omega will increase. Here omega will increase or decrease? Omega will decrease. Alpha will be positive or negative? Negative. It will be retardation or acceleration? Retardation. So this is acceleration and this is retardation. Give me an example of this.
Sir, stopping the fan.
Stopping the fan. Okay. Any other example? Cycle. Okay, tire. No, tires are not. Okay, you are moving with a constant speed. Now you apply brake. When you are applying brake, basically you are applying to the cycle tire. To that side, you are applying torque in opposite direction. If the cycle tire was rotating clockwise, you are applying brake. Still that it's moving clockwise only for some time. Then it stops because torque was acting anti-clockwise. Are you understanding this or not? Okay. Now this is a very important relation. You write this down. acceleration is constant, let me not say positive, acceleration is constant. That means acceleration is not changing with respect to time, but velocity is increasing or decreasing at a uniform rate. That's what we call as acceleration, right? Displacement time graph, velocity time graph. Okay, if velocity time graph is positive, velocity time graph slope is positive, acceleration is positive. If velocity time graph slope is negative, acceleration is negative. Slope of velocity time graph gives us acceleration. If the slope is positive, acceleration is positive. If the slope is negative, acceleration is negative. It must be a straight line because slope must be constant. Slope must be constant because acceleration must be constant. Okay, so here it's alpha, A is constant, here it's alpha is constant. Okay, now whenever what do you call such motion? Uniformly accelerated motion. How many equations we have? 3 equations. We can have more also, but 3 is enough. Okay. Now today I will tell you an extra equation also. It might help you. It might help you in solving quickly questions. Okay. I'll tell you. S is equal to Vt minus half AT square. S is equal to Ut plus half AT square. S is equal to Vt minus half. Easy to remember. If S is equal to Ut plus half AT square, S is equal to Vt minus half AT square also. If you have given final velocity and you have calculated displacement. Otherwise, you have to use 2 equations. Here, use 1 equation. You can't do it.
Can you
use in exams, but if teacher got confused, then explain. Okay. Now, acceleration is constant. How many equations? 3 equations. First equation, V is equal to U plus AT. V is equal to U plus. Now look here. Now look here. If V is equal to U plus AT, can I say final? This is final linear velocity, or that final angular velocity is equal to initial angular velocity plus alpha t. One you remember, another is easy to remember. Okay. Now next equation. Either S is equal to V square minus U square is equal to 2as. Or can I write 2a delta r also? Delta r also displacement, no?
Sir, like the other way, sir.
You know why I don't do it? 2a. Okay. Now here what will I write? Omega f square minus omega I square is equal to 2 alpha delta theta. That's why I wrote delta r there. You can write delta so that you will relate. Delta r, change in position is displacement. Change in position is displacement. So change in angular position is angular displacement. Okay. Now tell me. Last equation. S is equal to ut plus half AT square. S is equal to ut plus half AT square. S is equal to plus half AT square. Now S is equal to ut. Tell me ut plus half alpha t square. Should we have extra equation?
Yes.
Okay, if you have to find average velocity somewhere, they have given initial velocity, they have given you final velocity. In case of only uniform accelerated motion, and they ask you average velocity, this is important because they ask you. Okay, from these equations we get one more equation to find average velocity. To find average velocity, that is u initial velocity plus final velocity divided by 2. But where we should use this uniformly accelerated motion. Okay. Similarly here there also we can write one more equation which I told you. If you remember, well and good. If you don't remember, don't worry. Same equation. S is equal to Vt minus half AT square. You know why this is very beneficial? I will tell you why. This answer. That's the answer. Very easy, man. You see, very easy. Very easy. Okay. Now you know everything. Now you know everything. The angular speed of a motor wheel is increased. Is it acceleration or retardation? Acceleration. Net force will be in the direction. Net torque will be in the direction of omega or opposite. In the direction of omega. Alpha will get positive or negative? Positive. Okay, wait. If you take clockwise positive. Okay, from 1200 RPM means revolutions per minute, to 3120 revolutions per minute in 16 seconds. In 16 seconds. What is its angular acceleration? What is its angular acceleration? Let me break it for you. We know what is Ni, N1, basically initial RPM. What is initial RPM? 1200 RPM. What is the angular velocity? Initial angular velocity? 2 pi n by 60. So 2 pi into 1200 divided by 60. 006. 2 are 12. This is correct?
Yes.
So 40 pi? Correct?
Yes, sir.
Is it 40 pi?
Yes.
Okay. So answer is how much? What is initial angular velocity? 45. Just check whether I made a mistake. I might make a mistake. Now tell me. Now this is the initial angular velocity with which this wheel was. This wheel was rotating initially. If it was rotating with initial angular velocity Ni omega I, now I apply some torque. And increase its angular velocity. Increase its angular velocity to how much RPM? 3120. Convert. What is the final angular velocity? 2 pi into 3120 divided by 60. 0, 0, 6 5s are 30, 6 2s are 12, 5 2s are 4, 5 2s are 10, 104 pi. Are you correct or not?
Yes, sir.
104 pi? Okay. Initial angular velocity is how much? 40 pi. Final angular velocity is? In how much time is speed change from 40 pi to 145?
16 seconds.
Time is given also. How much? 16 seconds. U is given, V is given, T is given, U is given, B is given, T is given. What do we have to find? A. I am telling that way. Okay. Omega I is given, omega F is given, time is given. A is equal to B minus U divided by T. Basically, B is equal to U plus AT. Same thing. B is equal to U plus AT is same. A is equal to B minus U by T is same. Yes or no? But you know in 9th grade, A is equal to B minus U by T. That's why I will write alpha is equal to B minus U divided by T. B minus U divided by T. Tell me what is B? 104 pi. 104 pi. Minus which pi? 40 pi. How much time? 16 seconds. Can you tell me alpha?
4 pi radians.
What is 104 minus 40? 60?
64
by 60? How much?
4 pi.
4 pi. So it's 4 pi what?
Radians per
4
second.
pi radians per second square. Radians. This is its angular acceleration. This is angular. Is there any t or something here? No. So is it constant?
Yes.
It's constant angular acceleration. Constant angular, not constant angular velocity. Velocity is increasing. Yes or no?
Yes.
Do you understand?
Yes.
Okay.
Sir, the 10 runs are left, sir.
Huh?
Sir, break this.
What? 6:30 now?
Yeah.
Maybe time I break this, sir.
Translational equilibrium and rotational equilibrium.
Oh, come on, bro. How crazy are you?
What is translational equilibrium when the net force is
Zero.
zero? Net force is zero. Okay, and the net force is equal to zero. That means either the object will stay in the state of rest or uniform motion. Okay. Translational equilibrium basically simple. This we already have studied that if the net force acting on an object is zero, net force acting on an object is zero in all directions. In all directions where the net force is zero, the object is said to be in equilibrium. For example, this is the mass m. Okay. Someone is pushing this block with a force of let's say 6 newtons. 6 newtons. Okay. Someone is pushing from other side, let's say 6 newtons. What is the net force? Zero. Okay. Similarly, if mass is 2 kilograms, how much will be the mg force? How much will be the mg force? Mg force. How much will be the gravitational force? If mass is 2 kilograms, 20. 2 into 9.81 or 2 into 10, 20 newtons, right? This is weight. This is weight. Is there any other force upwards? Yes. Which force is that? Normal force. And this normal force equals exactly 20 newtons. Then this force will cancel this force will cancel this force. The net force will be equal to 0. Such a condition is called translational equilibrium. Similarly, we don't have force in rotation, we have net torque. When the net torque acting on an object is 0. When the net torque acting on an object is 0. In that case, the object will be in rotational equilibrium. Object will be in rotational equilibrium. Do you understand? I'll give you an example. Okay, in your childhood, have you played this game Seesaw? Never? Seesaw, for example. Seesaw. Now, there is a support in between, right? A support in between, right?
Yes, sir.
It's called hinge support. It's called hinge support. Or simply hinge. We call this as?
So 2 points are missing.
Okay, ma'am.
Two Hinge. What is this hinge? Hinge is basically if I hinge any object, okay, let's say I hinge this pen here. This is hinge support. About this, it's free to move, it's free to rotate, it's free to free to rotate. But it's not free to translate. It's not free to translate. If I pull it, it will not. Okay. If I push it again, it won't come off. Okay, but it's free to rotate. Such we call as such support we call as hinge support. Such support we call as hinge support. Now let's understand. Okay. Let's say there is an object on one side of this having mass 5 kgs. How much kgs? 5 kgs. Okay. Let's not assume any mass for this. Okay, this rod, whatever it is. Now, will there be force due to this? Right. How where? Downwards. How much force? How much force? 50 newtons. 50 newtons, right? Okay. Let's say from the other side we have
20.
let's say 10 kg object. 10 kg object. Yes, okay. 10 kg object. Okay. Let's say how much force will be there? 100 newtons. Okay, 100 newtons. Okay. Now if we balance torque about this point, about this point, about this point. Let's say this point is O. This point is O. Let's say this distance is 2 meters. How much? 2 meters. And this distance is 1 meter. This distance is 1 meter. Now how we balance torques? We will see how many number of torques, basically adding all the forces, adding all the torques. That's what we call as net torque. So what we call as net torque. This is F1 plus F2. For example, here if I calculate net force, F1 plus 6 Newton and tell me plus 6 Newton and minus 6 Newton. What is the answer? What is the net force in X direction? 0. Similarly in Y direction also 0. One direction we took positive, one direction we took is negative. Clear? Similarly here also we can balance in a similar way, but here we cannot take right side, left side. We can take clockwise positive, anti-clockwise negative, or clockwise negative, anti-clockwise positive. Let's say we take clockwise positive, clockwise positive. Can you tell me about this point, can you tell me how many forces are acting, one force and another force at a distance of 1 meter and 2 meter? Clear? If I want to balance net torque, I will say T1 plus T2, basically adding all the forces, right? All the rotational forces I am adding. Clear? If it is in equilibrium, it will become 0. It will become 0. Let's see. Tell me, torque 1. Let's say this is torque 1. Okay. What is torque equal to? Force into perpendicular distance. Called R cross F. R F sin theta. R F sin theta. This is R. This is F. What is the angle between them? 90 degree. This is R. What is R? 1. This is F. How much? 100. What is the angle? 90. What is sin 90? 1. So can I say basically perpendicular distance multiplied by the force? 100. Do you understand? So I can say 100 into 1. Let's take clockwise. Will it rotate clockwise this seesaw or anti-clockwise? It will rotate it clockwise. Okay. So I will take it clockwise torque. Clockwise torque. So I will write 100 into 1. 100 into 1. 100 into 1. I will take it positive. I took clockwise positive. I took clockwise positive. Do you understand? Or I can write either I can write plus 100 newtons or I can write or as why is it minus k cap. Minus k cap. That also I can write. But here it's easy. Okay, plus minus. Clockwise positive, anti-clockwise negative. Do you understand? Then tell me another torque about this point, right? 50 into 2. 50 into 2. So I will write 50 multiplied by 2. Should I take it positive and negative? So this is clockwise torque. Now one is clockwise torque, right? What is this torque? Anti-clockwise torque. So should I take it positive or negative? I will take it negative. See about this point, no? About this point. This provides clockwise torque. This provides anti-clockwise torque. Understood? Torque is always defined about that point. About that point or about the axis. About that axis. Do you understand? Yes. This is my axis of rotation. This is my axis of rotation. Are these two? What is this line? What is this axis? No, what is this axis called? Line of action. See, axis of rotation and line of action, skew lines. Are skew lines. Here also it is. Here also it is skew. Are you getting it?
When it's a 10 kg object, suppose if the seesaw it moves like this, so the
then either it will be little closer or its weight will be little
I
more.
don't understand how T2 is anti-clockwise, because if it moves like this, then this is
T2, Imagine about this point. Imagine about this point. How will this force try to rotate the seesaw? How will this force try to rotate the seesaw?
This will get downwards.
But then,
It will go upwards, right? Because it's
neither it will go upwards nor it will go downwards. It will stay. That's why I wrote rotational equilibrium. Rotational equilibrium means both torques will cancel out each other. Like both forces, both forces cancel out each other. Both torques cancel out each other. Because this is also 100 Newton. This Newton meter. This is also 100 Newton meter. Are you getting my point? So what is the torque? Net torque is zero. Net torque is zero. Such we call as rotational equilibrium. Rotational equilibrium. Do you understand?
Yes, sir.
Is it clear? Okay. Is it in translation equilibrium?
Yes.
Definitely it is in translation. If it was not in translation equilibrium, it would either go up or down. Does seesaw go up or down? No. That means there must be a force. There must be a force that is upwards, just like normal force. Okay. Basically normal force only. Normal force only. But we call it by a name as hinge force. We call it as hinge force. Call it normal force. Call it normal force. Can you tell me how much will be the normal force? 150. Upward force will be equal to downward force. So normal will be equal to the normal, because the net force is also equal to 0. If net force is also equal to 0, I will write the normal will be equal to 100 plus 50. How much is that? 150 Newton. So this object is in translation equilibrium also and rotational equilibrium also. Similarly, this is also in translation equilibrium and rotational equilibrium if it does not rotate. Okay? But again here I have not shown it. So this is that. Okay? We usually calculate about center of mass. Okay? Torques anyhow. Understood? Is it clear? Yes or no?
Yes, sir.
So what is the rotational equilibrium?
when the net torque is zero.
Net torque is 0. What is translation equilibrium? What is complete equilibrium?
When both are rotating.
I will tell you one. I will tell you. If net force is 0, but net torque is not equal to 0, object will only rotate. Object will only rotate. It will not translate. It will not translate. It will perform pure rotational motion. It will perform pure rotational motion. Understand this? Now, if net torque is 0, but net force is not 0, in that case, it will only perform translational, pure translational motion. If net force is also not equal to 0, net torque is also not equal to 0, it will perform CTRM. It will perform CTRM, combined rotational and translational motion. Now, you tell me,
Yes.
if it's accelerating, if it is accelerating, if it is uniform motion, what is net force? Imagine this. So see, if it is uniform motion, what is net force? 0. If it is at rest, what is net force? 0. Now, if it is accelerating, what is net force? Not 0. What is net torque? 0. Because it's not rotating. It's not rotating. Tell me, what is net force? 0. What is net torque? 0. If it is moving with a constant angular velocity, then net torque is also 0. Do you understand? Net torque is also 0.
Yes, sir.
Because here it's rest and uniform motion. Here it's rest or uniformly circular motion. Uniform circular motion. Now, you tell me, what is net torque and net force?
Non-zero.
Is net force 0?
No.
If it's accelerating. Is net torque 0?
No.
Now, you see a tire. See a tire. It's moving forwards also and it's rotating also. Neither the net force is 0 if it's accelerating both ways. Okay, if it's accelerating uniformly, accelerated circular motion and uniformly accelerated forward motion. Then neither the net torque will be 0 nor the net force will be 0. Now you have understood everything. We have combined everything, compiled everything. Understood? Is it clear?
Yes, sir.
Yes.
Write it down. See, two small things. One weighing 10 kg, one weighing 10 kg, another weighing 15 kilograms. Respectively, are trying to balance a seesaw. Of total length, how much? Of total length, how much? 5 meters. So imagine this is 5 meters, okay? And here one kid have a weight of 10 kilograms. 10 kilograms. How much force? How much force if we take G as 10? mg is now 100 newtons. 100 newtons. Okay. Now, okay, the total length is 5 meters. Okay.
Yes, sir.
With the fulcrum, or this, it's called fulcrum also. It's called the hinge support also, right? Hinge. At the center, exactly at the center. If one kid is staying at one end, if one kid is sitting at one extreme end, where should the other sit? Where should the other sit so that it will balance? That torque will balance. Now, what it is saying is total is 5 meters length. Okay, one is staying at the extreme position. How much? 2.5 meters. How far? About this point it will rotate. About this point it will rotate. about this point it will rotate. Okay, I will make it right also. Okay, make it right also. One kid is sitting on the extreme position, another kid is sitting somewhere. Where should he sit? Where should he or she sit? Okay, weight is how much? 15 kilograms. How much force? Not mass is 15, not weight. Okay, weight is how much? 150 newtons. Weight is how much? 150 newtons. How far should he sit from the center point so that they will balance, so that the torques will balance each other? Look here, please pay attention, please pay attention. Let's say this is kid A, this is kid B. Now the net torque must be equal to, net torque must be equal to
0.
Net torque must be equal to 0. Only then it will be in equilibrium. Okay. Now, should we take clockwise positive or anti-clockwise positive? Clockwise as positive. Clockwise as positive. Okay. So now tell me how much torque 150 into x. 150 into x. What is that? 150 into x. Positive or negative? Positive. Okay. This is clockwise torque. This is clockwise torque. Let's say this is T1, and this torque will be anti-clockwise. How much will be T2? Tell me. Minus 100 into 2.5 will be equal to 0. So x will be equal to 250. What is it? 250 divided by 150. So how much is the answer? 1.6 meters. 6 okay meters. Okay. Now if anyone asks you, what is the normal force of the hinge force or normal force on the hinge force? Okay, normal force is equal to 250 because the net force is also equal to 0. If net force is equal to 0, it's in translational equilibrium also. So I can say upward force is equal to downward force. Normal force is equal to 250. This normal force will not provide torque. Can you answer me this? Why?
Because
it's intersecting. The axis of rotation and its axis. This is axis of rotation. This is its line of action. Line of action and its axis of rotation is intersecting. For it, it's skew line. One line, two lines. Skew line. This is also skew line. What is it? Skew line. Now you write question.